Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, the atomic structure. Today we will begin with lecture 28 from the course, but make sure you have watched the previous ones before viewing this one. In the last lecture, we learned how to write the electronic configuration of various elements. And in this lecture, which is going to be the concluding lecture for this course, we are going to see a few numerical problems based on the electronic configuration. So let us begin with this lecture. The first question we have is, consider the following configurations. First is 1s2 2s1 and the second is 1s2 3s1. The first part of the question says you have to name the element corresponding to configuration 1, and then the B part says does the configuration 2 correspond to the same element, and then how can 2 be obtained from 1. Well, if you consider now the configurations 1s2, 2s1, what does this mean? Well, this means that it has 2 plus 1, 3 electrons, right? So 3 electrons, the atomic number of the element which is going to be equal to the number of electrons is going to be 3. And the element which is having atomic number 3 is lithium, right? I request you all, please do remember the name of the elements up till atomic number 30, right? This is what is going to help you solving questions like this. You should remember till atomic number 30 at least the electronic configurations, the atomic numbers and the name of the elements. Now, the second part of the question says that does configuration 2 correspond to the same element? Well, the configuration is what? It is 1s2, 3s1. So again here the number of electrons is what? It is again 3. So this means that as the number of electrons is 3, the configuration is going to correspond to the same element lithium. And how have we got this configuration? Well, this configuration is because of the excitation of the electrons from the lower energy levels into the higher energy level, right? So configuration 2, this is the excited state of lithium and we can obtain it from 1 by supplying energy required for the excitation. I hope this question is clear now. So now the second question says write the symbol of the atom whose electronic configuration is 1s2, 2s2, 2p6 and give one negative ion and one positive ion corresponding to the same configuration. So first of all we have the electronic configuration as 1s2, 2s2, 2p6. So this means this has 10 electrons. So 10 electrons, the number of the protons has to be 10. So the element which has atomic number 10 is going to have the symbol Ne, that is the element is neon, right? So that is why I've told you that you have to remember the elements with their atomic numbers till at least 30. Okay, and then you have to give one negative ion and one positive ion corresponding to the same electronic configuration. This means that these ions should have the same number of electrons. The ions which will be having the same number of electrons as neon, right? These are going to be called as isoelectronic species, right? The species which have the same number of electrons, they are called as isoelectronic species. So we want to write the isoelectronic species as neon, one negative and one positive. So we have fluorine with the atomic number 9. When the atomic number 9 means 9 electrons and then we add 1 electron, we will get 10 electrons, right? So fluorine, after gaining 1 electron, this becomes F negative and this is the negative ion which has electronic configuration similar to neon. Similarly, we have to have one positive ion. So positive ion, this means this has to lose one electron. So losing one electron is going to be from the neutral atom, which has atomic number 11, and that is sodium. So sodium on losing one electron will have 10 electrons, and hence the ion we have is sodium positive, Na plus. Right? I hope the question is clear that we have to write the electronic configuration. We get the atomic number from that, and then we can write the name of the element. And to have the ions corresponding to the same configuration, the number of electrons has to remain same. They are going to be isoelectronic species, and you have to just see the element with atomic number 1 less than neon to get a negative ion, and 1 more than neon to get a positive ion. Okay. Now the third question we have is write the electronic configuration of metallic ion in sodium sulfate. Okay, and Z for sodium is 11, sulfur is 16, and O is 8. This is given to you. Now, which is the metallic ion in this configuration? Well, this is sodium. So we have to write the electronic configuration for Na plus. So the number of electrons in sodium, as we've discussed earlier also, was what in the neutral atom? It was 11. And now it is going to lose one electron to become Na plus. So it is going to have 10 electrons. And when we write the electronic configuration for Na plus, it is going to be 1s2, 2s2, 2p6. So these are the way the questions are asked. I am trying to just give you an example how the questions are based on the electronic configuration. So next we have what fraction of the total number of electrons is in the p subshell in beryllium, magnesium and iron. So what you will do over here, you will write the electronic configuration for these elements, and then you will see how many electrons are going into the p subshell out of the total electrons, right? So first of all, for the A part, the electronic configuration of beryllium with atomic number 4 is going to be 1s2, 2s2. And this element has no electrons in the p subshell, as you can see the electronic configuration. So the fraction of electrons in the p subshell is 0. Next we have magnesium. Magnesium has atomic number 12. So the configuration is going to be 1s2, 2s2, 2p6, 3s2. And this has 6 electrons in the p subshell out of the total 12. Right? So the total number of electrons is 12. 6 are in p subshell. So the fraction is going to be 50%. Next we have as iron. So the electronic configuration of iron with atomic number 26 is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 and 4s2. And how many electrons are in the p orbitals? 6 of 2p and 6 of 3p, making it 12 electrons in the p subshells out of the total 26. And this is going to make the fraction in the p subshell to be 46.15%. Next question we have is how many subshells they are associated with n equal to 4. Then the second part of the question says how many electrons will be present in the subshell having the value of -12 for n equal to 4. And now the solution, right? So for telling the subshells with associated n equal to 4, when n is 4, the possible values of L are going to be 0 to n minus 1. So these are going to be 0, 1, 2 and 3. Therefore, we have 4 subshells for n4, that is 4s, 4p, 4d and 4f, right? Now coming to the second part. Second part says that we have to tell how many electrons in the subshell of n4 will have -12 value. So do you know the number of orbitals in a shell? This is n square. So in the fourth shell we will be having how many orbitals? 16 orbitals. 16 orbital means that there are 32 electrons in these orbitals, and out of these 32, 16 will be having minus half value and 16 will be having plus half value, right? So each orbital, this has one electron with the spin quantum number ms as minus half. The spin quantum number is written as single small s also, and also denoted this way with ms, m and ns in the foot. Okay, so each orbital with one has one electron with a spin quantum number minus half. So this means that the number of electrons with spin quantum number minus half is going to be 16. Now the next question says that unpaired electrons in aluminium and silicon, they are present in the 3p orbitals. Which electron will experience more effective nuclear charge from the nucleus? One in aluminium or one in silicon? Well, to have the effective nuclear charge being understood, what do we have to see? We have to see how many electrons there are in the inner shells which are repelling the outer electrons, right? And then we have to see the total nuclear charge that is in the nucleus. So the number of repulsions from the inner shell electrons is going to be the same for aluminium and silicon, both being present in the 3p orbitals. So what is going to matter over here is the nuclear charge on aluminium and silicon. The nuclear charge in case of silicon is plus 14, aluminium it is plus 13. So the nuclear charge in case of silicon is more than aluminium, and hence the unpaired 3p electron in case of silicon, this will experience more effective nuclear charge. We will be discussing this more in the course of the periodic properties. The next question we have is the quantum number of 6 electrons. They are given below. You have to arrange them in order of increasing energy. List if any of these combinations have the same energy as well. Okay, so this is the set of combinations that are given to us. What do you have to do over here to arrange them in order of increasing energy? If you remember the energy level diagrams, how did we arrange them? Yes, we arranged them by seeing the n plus L values, right? You remember? Okay, so what we will do is we will see the n and L values for these electrons and see what are the orbitals they are occupied by these electrons, right? So let us see that. For the first we have N4 and L2. So this is going to be 4 and L2 is D. So we have 4D. For the second it is going to be 3 and 2. That means it is 3D. Third is 4 and 1. So it is 4P. The third is 3 and 2. That is 3D. Again, fifth is 3 and 1. This is 3P. And it is 4 and 1. So the sixth is 4P. Now you see the N plus L values for them. So the N plus L values are going to be 4D is going to be 6, 3D is 5, 4P is 5, 3D is 5, 3P is 4 and 4P is 4. So which is the value which is the lowest of them all? It is going to be 4. So the 3p electron, this has the least energy, right? Now the next energies, they are of what? All 3D, 4p, 3D again and 4p again, they have 5 as the N plus L value. So 3D electrons, they are going to have a lower energy than the 4p electrons because the N value is less, right? So first of all, you have to understand this, that 3D and 3D, they are going to have lesser value than 4p of the third choice and this sixth choice 4p again. Now the 4p electrons, whether they are present in whichever orbital px, py or pz, they are going to be degenerate orbitals. They will have same energy. Similarly, the 3d orbitals, they will also have same energy. So the second choice and the fourth choice, they will be having same energy. And the third choice and the sixth choice, they will be having same energy. The highest energy will be of 4d, right? So the order we have is the least energy of 5, which is less than 2 equal to 4. So what is 2? 2 and 4, right? And then we have 6 and 3, which are having another higher energy, and the maximum energy is for the first choice, that is 4d electron. I hope this is clear, and this is a question, one of a similar question was asked in the JEE Mains examination for 2019. So you can understand that this type of questions, they are really important and you should understand them well. The next question is that you have to indicate the number of unpaired electrons in phosphorus, silicon, chromium, iron and krypton. So you have to write the electronic configurations for them to tell the number of unpaired electrons. Phosphorus atomic number 15, the electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3px1, 3py1 and 3pz1. So you can see that there are 3 unpaired electrons in case of phosphorus. Then similarly we have silicon, just the atomic number is 14. So write the electronic configuration and you see that there are 2 unpaired electrons in case of silicon. Then moving on to chromium with the atomic number 24. You have to remember that the electronic configuration for chromium is not 3d4 4s2, but it is 3d5 4s1. And all these 5 electrons, they are going to be in different orbitals. So this means that the number of unpaired electrons is going to be 6. 5 from 3d and 1 from 4s. Then we have iron with atomic number 26, and again if you see over here we have 3d6. So 3d6 means that there is pairing of one orbital of the d subshell, and that means 4 electrons will be unpaired over here. Then we have krypton with the atomic number 36, and here if you write the electronic configuration, you will see that there are no unpaired electrons and krypton is a noble gas. Next we have is an atom has 2k, 8l and 2m electrons, and you have to find the total number of protons, principal quantum number, sub-level or sub-shells, orbitals, p electrons, paired electrons, unpaired electrons, valency of the atom and number of orbitals for this atom. So many things that you have to tell, but they are all very easy. So first of all, you have how many electrons? 2 plus 8 plus 2. So this makes it 12 electrons. So 12 electrons, so this means the number of protons is equal to the number of electrons, and hence this is 12. So first part gone. Second is asking the principal quantum numbers which are present. So the principal quantum number, write the electronic configuration for this element and you get this as 1s2, 2s2, 2px2, 2py2, 2pz2 and 3s2. So how many principal quantum numbers can you see over here? 1, 2 and 3. Next we have to tell the number of subshells. So the number of subshells you can see over here is 1s, 2s, then we have 2p and 3s, making it 4 subshells. Next we have to tell the number of orbitals. So the number of orbitals also you can calculate from the electronic configuration. It is going to be 1s, 2s, 2px, 2py, 2pz and 3s, making it 6 orbitals. Then you have to tell the number of p electrons. So again that is going to be very easy. Just see the p electrons, there are 6 of them. And then the paired electrons. So all of these electrons you can see they are paired. There is no unpaired electron, which is the G part. So the number of paired electrons is 12 and the number of unpaired electrons is 0. Now to tell the valency of the atom. So valency is the combining capacity of an element, and that is equal to the number of valence electrons over here in this case. We will be discussing the valency in detail when we discuss the course on periodic properties. But for here you can say the number of valence electrons in this element is 2, that is it is 3s2, and this can lose these 2 electrons to combine with another element, and hence the valency of the atom is 2. This element, if you know by now, is what? This is magnesium, right? And if you think of a formula of any compound magnesium makes, first thing that strikes my mind is magnesium oxide. So oxygen has the valency -2, magnesium is +2. So this means that the valency of this atom is 2. How we do it for the rest of all the elements, that you will be able to appreciate when we do the course on periodic properties. And finally, we have to tell the number of orbits. So the number of orbits is going to correspond to the principal quantum numbers that we can see. So there are 3 principal quantum numbers. So the number of orbits is also going to be 3. The last question for today is write the electronic configuration of chromium +2 and manganese +4 ion, and you have to give the number of unpaired electrons in each case when the atomic number of chromium and manganese given to you as 24 and 25 respectively. So you have to write the electronic configuration, and while you have to write the electronic configuration for the ions, it is better first to write the electronic configuration of the neutral atom. So for the neutral chromium atom, we have the electronic configuration to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d5 and 4s1. Now this chromium has to lose 2 electrons to form a cation, right? And if you remember, I told you to become a cation, to lose electrons, it loses electrons from the outermost shell, right? So the first electron to be lost is going to be 4s1, and then one more to lose, it will go to the 3d or electrons and lose 1 electron over here, making it 3d4. So we have the electronic configuration from chromium +2 to be 1s2, 2s2, 2p6, 3s2, 3p6 and 3d4. Similarly for manganese, first of all write the electronic configuration for manganese, which is going to be 3d5, 4s2. Now you have to lose again 4 electrons to form manganese +4, and here you are going to lose first 2 electrons from 4s and then 2 electrons from 3d. Okay, so the electronic configuration is going to become 3s2, 3p6, 3d3. I hope this is clear how we write the electronic configuration for the ions. This is really very important for you to understand. And then you have to give the number of unpaired electrons in each case. So you can see the electronic configuration here. We have 3d4, so it is going to be 4 unpaired electrons, and Mn +4 is going to have 3 unpaired electrons. Right? I hope it is clear. So that would be all for this lecture. I have really enjoyed my journey in this course with you people. I hope you have done with me. So please do join me for the next course on periodic table and periodic properties, which is already available on our channel H2O. So please do subscribe to the channel to get a notification for all the courses that we are putting up for you. Well, this course is already available. Some of the lectures we've already discussed. So if you have not started, please do start them. Right? And then to get a notification of the new lectures we will be putting from this course, please do subscribe to the channel and click on the bell icon as well to get the notifications quickly. If you have any doubt from the whole course, from anything in chemistry, you are free to mail us at h2ochemistry@gmail.com, or you can even put that in the comment section. We will be glad to help you all. And now one final request. Well, if you liked the lecture, please do click on the like link as well. Thank you. Have a nice day. Enjoy yourself. God bless you.